Coming up on the PEDcast, a look back at a conference on soil sustainability. We spotlight the phosphorus research from an early career researcher. Regular contributor Nick Skinner has more words of wisdom for early career researchers. And the first of a 6-part series of videos from Cool Planet and the future of agriculture. Welcome to the PEDcast. I'm Dan Evans. Well, the last time I presented the PEDcast, I was in the sunny climes of Rio de Janeiro in Brazil for the World Congress of Soil Science. That sunshine that couldn't quite fit in my suitcase. You know what baggage restrictions are like. But anyway, it's the end of October and the leaves have started to fall, which must mean it's autumn. And you know what leaves create? That's it. Good quality soil. Since the World Congress though, the British Society of Soil Science has had their annual conference on soil and the Sustainable Development Goals. It was a packed conference, full of interesting topics, ideas and discussions about how to make soil more sustainable. Here's a montage from BSQ with a few highlights from the event.
The topic of this meeting, Soils and Sustainable Development Goals. It is, of course, a highly appropriate topic to have a meeting about.
The Soil Conditions and Plant Growth book has been central to the evolution of soil science and the training of soil scientists across the world.
I'm quite honored to have been invited, especially to the Russell Lecture. It is a book. I can still see the cover of it. We still have it on our shelves at home.
Health and nutrition are included in both goals 2 and 3 in the SDGs.
We are more, we consume more intensively and under changing and more challenging conditions.
We've been taking out a load of our sensors because they have the knowledge, they don't have the facilities necessarily.
In combination with fertiliser, our biochar appear to increase yield in the lowest nutrient, most acidic soils.
We want to grow more fruit and veg, but can we grow it in a more sustainable way?
The PEDcast is very excited to announce that we have been given permission from Cool Planet, an agriculture technology company focused on soil health solutions, and the future of agriculture, a USA podcast on food security and sustainability, to broadcast one of their most recent series called Stories from the Soil. Stories from the Soil is an educational series. It's based in the USA and is about soil health management practices. Cool Planet and the future of agriculture travelled across the country and captured stories from the ground level, talking to land stewards, to growers, to farmers, and to leading researchers. In the first Story from the Soil, Cool Planet's president and CEO Jim Law explains the motivation behind the series and how Cool Planet is innovating soil health management tools.
There's a lot of research out there about soil health and a ton of technical information, but none of it does us any good unless we can see how it actually takes place at the ground level. My name is Tim Hamrich from the Future of Agriculture podcast. Cool Planet and I are going to travel the country and capture stories about how land stewards and growers and farmers are actually developing their own soil health and how that impacts their lives and the food they're growing for you.
Our first episode brings us to Johnstown, Colorado, where I meet up with Jim Lohr, President and CEO of Cool Planet.
Well, Jim, I'm really excited about this series, Stories from the Soil. I'm curious, though, from Cool Planet's perspective, why invest in a project like this?
Well, Cool Planet is a company dedicated to innovation, technology development for agriculture. We have a strong company and a strong team that are dedicated to that. You know, in my career, concepts, ideas, answers, solutions best come from farmers. And so we're excited to listen to people in the industry, people who are knowledgeable about agriculture, about soil health.
Soil to me is so much more than the media that we use to grow plants. I mean, it is biologically active, it is diverse, and I think we're going to get to see some of the diversity in this series. It is literally the groundwork for our agricultural system, and I think even with modern advances in technology, even with hybrids, even with genetic engineering, even with precision agriculture, we still rely on the soil being healthy for our long-term sustainability. And so I think agriculture has done amazing things when it comes to productivity and efficiency. I think if we're going to continue that curve throughout the next several generations, we need to put the soil first and then build technologies like you are, which work with nature and not against it.
From a farmer's perspective, sustainability is great. I think they're probably the most sustainable people in the world, but they have to do it profitably too. So we need to be bringing them tools that help them with productivity and profitability. Let's take Coolterra for example, a fixed carbon material that goes into the soil that basically provides a habitat for the soil biology.
And what I love about what you're doing is that you can show effectiveness and profitability in the first year while building that long-term soil profile. And those are the solutions we need, especially as the farm economy struggles.
Agriculture is humanity. Agriculture is people. Agriculture is the grandfather, the grandson who's out there farming the land. Hearing what their issues and thoughts are is important. Stories from the Soil is going to help us look at a wide cross-section.
Well, I'm excited because I usually get a chance to talk a lot about this stuff, but not a chance to actually visit in person and to get out there and to sit down with these growers and really understand how they're looking at soil health is something that I think is going to be extremely valuable, as well as getting different perspectives from all around the country. So couldn't be more excited to get things kicked off.
Should be a little fun too.
Oh yeah, I can't wait.
Well, that was the first story from the soil, as produced by Cool Planet and the Future of Agriculture. You can see more information about their series on the link below. And next month on the PEDcast, we will bring you their second story, Making Sense of Soil Science. But first, here's our regular contributor, Nick Skinner, from Poppyfish People Development, with more words of wisdom for early career researchers.
Now, the reason I do what I do is because I'm a massive believer of the human in the system. And so I like to watch people and I like to see people engage with other people at work. And I know that although some of us work really well independently, it's really important that we keep our head up and engage with other people. And I think what the best researchers, engineers and scientists that I've worked with have been able to do is have that level of engagement with people around them at work. So science is an area where you are constantly, or we look at it from the outside and say this person is peering down a microscope. You're spending your life looking at smaller and smaller things, converging your thinking into looking at this one thing. Sometimes we can get better outcomes by stepping back a little bit and looking at that in our environment around us and being human with the people that we work with. So this is around taking time to meet people who come into your team, finding out a bit about what their background is and where they're from and what their research interests are. This ties into the ability to build networks. I think if you can do that as a scientist, then you're going to have an idea for somebody you can go to when a theme of interest comes up. So it's about taking your head up from the microscope, every now and then doing it in quite a formal way actually, and saying, well, maybe I'm going to share my ideas with people that I work with. Maybe at the next laboratory meeting I'm going to present what I'm working on, or invite other people to present what they're working on. And we can share things more and have more of a collaboration, chance to discuss what we're doing, rather than me going further and further and further and further into this fascinating area of study. But to be honest, it's probably only fascinating to me and about 2 other people on the planet. It's really easy to get sucked into that, but it's around putting your head up and saying, okay, oh, what's that guy doing over there? Maybe we can go and do some stuff together. Oh, what's she doing over there? That looks really interesting. That's a new technique. I've not learned that before. And I think that the guys that I work with have done that really effectively, have been able to connect with the people that work around them, get deeper understanding of what they do, and as a consequence have better conversations and build better research networks.
On the PEDcast, we're especially interested in the work of our early career researchers. You're very welcome to come on the PEDcast and share the work you've been doing. This month, we take a pick from the STARS video collection. Malika is a PhD student in the STARS programme, and here she is now presenting some of her research on phosphorus.
Phosphorus forms a part of DNA, so is one of the major limiting nutrients for all living things, including plant growth, so therefore plays an essential role in food production. Humans impact the global phosphorus cycle by mining rock phosphates, a finite and geographically restricted resource, and then applying it to land as phosphate fertiliser. The challenge then is keeping it where the crop needs it and preventing it from entering natural environments or ending up in landfill. So efficient and sustainable management of phosphorus when it's in the soil can play a key role. For plants to use phosphorus, sufficient levels need to be present as inorganic forms at the root zone, the rhizosphere. But up to 90% of phosphorus fertiliser becomes unavailable to plants following application, and this is predominantly due to 3 main processes: adsorption onto soil constituents and precipitation to soil minerals such as aluminium, calcium and iron, immobilisation into organic forms by microorganisms, and transfer to waterways due to runoff or leaching. So, what are some of the methods we use as soil scientists to increase our understanding of soil phosphorus to help improve sustainable management? Determination of phosphorus in soils usually involves extraction, concentration and detection steps. Chemical fractionation methods are popular, relatively straightforward and affordable, and give us some information on the relative solubility of different phosphorus pools. However, the amount of phosphorus extracted with these methods will depend on soil composition and is only operationally defined. I'm really interested in the biological dynamics at the rhizosphere and how they affect plant uptake of soil phosphorus. As inhabitants of the rhizosphere and bulk soil, microorganisms play a critical role in phosphorus dynamics. Such influential organisms include nematodes, bacteria and fungi. Microorganisms may directly affect phosphorus solubilization and mineralization, impact on root structure and function, or immobilize readily available sources of phosphorus so they are no longer available to plants. Determining microbial soil phosphorus has traditionally utilised fumigation techniques and is often used alongside chemical fractionation methods to quantify the soil phosphorus pool which is found in microorganisms. Employing genetic techniques can help us identify functional groups and specific functional genes in soil phosphorus transformations. In situ methods are able to give us a very useful visualisation of the root-soil interface. With this rhizobox setup, we can see changes in root morphology, and with further analysis, such as zymography, we're able to visualise phosphatase activity. Phosphorus is cycled over diverse temporal and spatial scales, from the microscopic to global wind drifts. It incorporates lots of disciplines because geological, chemical, biochemical and biological processes all play a key role in phosphorus dynamics. This presents lots of challenges when trying to understand soil phosphorus, but for me keeps it really exciting and diverse. If we want to close the loop on the global phosphorus cycle and manage it more sustainably, the soil is a really good place to start.
Rest a while. In memory of Reen and Roy Wyman, 2007. I don't mind if I do actually, it's a lovely place for a rest. But if you're not interested in resting over the next couple of months, here's a list of events that you might be interested in. On Wednesday the 28th of November, there's a meeting to discuss the dimensions of natural flood risk management. It will be held at the Newton Rigg College in Penrith in Cumbria and will provide an overview of current thought and practice related to soils and natural flood risk management. To register for the event, head to the BSQ website. And later in the year, on November the 21st, you can attend an agricultural land classification course. This course, designed and presented by agricultural land classification experts from Natural England and the Welsh Government, offers a unique opportunity to learn about the background and technical basis of the current ALC guidelines. For more details and to book, once again, head to the BSQ website. And next year, the PEDcast will be once again at the European Geosciences Union Conference in Vienna, and I'll be convening a session on change across soil interfaces. It's a session that will spotlight the wealth of processes which occur across all soil interfaces. Abstracts can now be submitted. To submit an abstract to this session, go to www.tinyurl.com/soil-interface. Well, that's about it for this month's PEDcast. I do hope you've enjoyed it. If you've got any questions or comments about the programme, you can email them to me at student@soils.org.uk. But until the next time, whether you're trick or whether you're treating, goodbye.